Hello guys, what's up? Today I'm gonna solve the questions that you want to be solved from me. Let's get started. Question 1 is the number 7, page 41. So here asking the SKL, the equivalent resistance between KL and then C2 also equivalent resistance KL, but the S1 is when the X is short circuited, S2 is the when the Y is short circuited. What happens now? Let's analyze that. Now what happens when the X is short circuited? As you see that we draw a line like that. Why we are drawing that? Because animal charges prefer this way, not going on through this capacitance. When you draw that, you short circuited and then this X is cancelled. Only Y and Z is here. So for parallel circuit, you know this one we are using this one. So the one C1, C2 is parallel. The C equivalent is going to be the sum of C1 and then C2. So the equivalent resistance is C plus C. C plus C becomes 2C. What about the Y is short circuited? So this is important point. Y, and not only Y short circuited, but also Z is short circuited. Why? When we draw the line here, both is short circuited. So only there is X. So the C equivalent between KL only X capacitance. So this one is the C. So what's the ratio? 2C over C equals 2. Okay, I hope you understand. Let's look at the next question. You asked in this question, asking the relationship between V1, V2 and then V3. How to solve this question? So we have to know that if it's the parallel, as you see that I showed again, if it's parallel, V1 is equal to V2. So here we can write now V2 and then V3 is equals each other. Okay. So what is the next? We are gonna find the C equivalent when they are series combination. What's gonna happen when they are series? We are using this one. When they are series, so it's the 1 over C equivalent is equal to 1 over C1 plus 1 over C2. So let's write now C and then C, 1 over C plus 1 over C. C equivalent is equal to 1 over C plus 1 over C. So the 1 over C equivalent is equal to 2 over C. So the C equivalent becomes C over 2. So this one becomes C over 2. Okay. So what about now our new, how the parallel circuit becomes C over 2 and then C. So what happens if they are parallel? If they are parallel, we are just adding, as you see that, C1 plus C2. So the C equivalent here, C plus C over 2 becomes 3C over 2. And then when we write the new circuit, becomes like that. So this one is the 3C over 2, this one is the 3C. Okay, what we have to know, this one is the V2 or V3, the same each other, here the V1. Okay, so what we have to know about series combination, this one. So the Q1 is equal to Q2. So this one is, if you write the Q1, if you say Q2, Q1 is equal to Q2. So what's the relationship between QCV? We can put here. So the Q is equal to CV. So for each one, when we write the V becomes Q over C. Can you see that? So let's look at this V1. What if we say both is Q over 3C, but V2 and then V3, what's that? Is the Q over 3C over 2. It goes up to Q over 3C. So which one is bigger? Of course this one is bigger, and then bigger than V1. So we can write that V2 is equal to V3 and then bigger than V1. I hope you understand. Let's look at the next question. Okay, next question here. Asking for the relationship between the Q1, Q2 and Q3. Those are charges stored in capacitors. Okay, what we are doing here, so you have to know this for series combination. Q1 is equal to Q2 and Q1 is equal to Q2. We have to know that. Okay, what's next? We have to find C equivalent for series combination. Again, what's that? Is the 1 over C equivalent is equal to 1 over C1 plus 1 over C2. So let's write that for C equivalent between C1 and then C2 is equal to 1 over C plus 1 over 2C. So 1 over C equivalent equals, this one is the 2, 3 over 2C. So C equivalent 2C over 3. So our new circuit becomes like that. Okay, so this one is the 2C over 3, this one is C, and then this one is Q, let's say Q1, and then this one is the Q3. And what's the relationship between parallel circuit? So we have to show that. So the V1 is equal to V2. Okay, now here the V is equal to this V is the same. So when we write that V for the upper half, the R, V is equal to Q over C, you know that, Q1 over 2C over 3. What about this one? V is equal to Q3 over C. So when we write that, Q1 is equal to 2VC over 3, but Q3 is equal to VC. Which one is bigger? Of course, this one is bigger. So we know that if the Q3 is bigger than Q1, Q1 is equal to Q2. Okay, the relationship, this one. Let's look at the next question. According to this graph, when they are charged by batteries of the same potential difference. This point is very important. Here says the same potential difference. So what happens? The same potential difference. Here we are going to choose the same potential. So if I draw this one is like that, it becomes 4Q. Why? Because if the 2Q is U, for 2U becomes 4Q. Why I did this one? Because I find the same potential, okay, for the same potential. So what is the formula for energy? What's the formula for energy? This one. So we know V and Q. Which one is good for you? So this one is good. So the energy, or V, K, is equal to if it's the Q times V, so you take it half times Q times 2u. What about VL omega L half QV L? So half times Q is 2Q, U is 2U. What about VM half times Q times VM? So half, so what about Q, 4Q times 2U? So when you calculate that, as you see, this one is the 8, 4 times 2, 8, this is 2 times 2 is 4, 1 times 2 is, so the biggest one is the VM, and then VL, and then VK. I hope it's useful. So what about the next question you ask to me? Okay, this one, what is the equivalent resistance between K and L? It's easy. Anymore, I don't want to show after that. So if they are parallel, we are using C1 plus C2. So this one, C plus 2C becomes 3C, because 2C plus C. And then this one is also the same, 4C plus 2C becomes 6C. What about they are series combination? So I am using 1 over CKL equals 1 over 3C plus 1 over 6C. So when I write that, expand with 2, 1, 3 over 6C, so the CKL becomes 6 over 3, 2C. Okay, what about the next? Here again, the equivalent resistance between KL or KM. This one is important. Why? Because if asking for KL, this one is not related with KL. Okay, this one is cancelled. What about another one? Another one becomes like that. Actually, this you are confused to understand this circuit, but we can write like that. So anymore, this one is cancelled, so this one is CC. So what about the C1? C1 is now between the equal resistance between KL. So if they are series, so becomes 1 over C plus 1 over C, C over 2. So C1, if that one is the C over 2, now C and C over 2 becomes parallel. If they are parallel, just you are adding to find the equivalent. C plus C over 2 becomes 3C over 2. Okay, what about Km? So Km, no need to cancel anyone because start from here and then ends here. Okay, now let's draw the easy circuit, how it looks like. So I suggest you can use this method. If there's K, this point is K, this point is L, as you see that. But this M, there's a capacitor. This point is a different point. This is, let's say, N. Here the N. Okay. So how to do it? That K, L, N, M. So what's the between K and L? There is a one capacitor here. And then what about Ln? There is one more capacitor here. What about Kn? There is one more capacitor here, but Kn this point, okay? And then what about Nm? There is one more here. So all becomes like that, how the circuit. So you know that C and C is series, becomes 1 over C equivalent is the C over 2. So C over 2 and then C parallel becomes adding just 3C over 2. So C over 2 and then C. So what is the equivalent resistance here? 1 over C equivalent, because series 1 over 3 C over 2 plus 1 over C. so the 2 over 3c plus 1 over c. Here when you have the expand with 3, it's gonna be the 5 over 3c. Now as you see that you cannot see, here it's gonna be 5 over 3c, and then it's gonna be opposite 3c over 5. When you write here ckl, we found that for the first one is 3c over 2, and then the next one is the 5 over 3c over 5. So 3c over 2 times 5 over 3c becomes 5 over 2. Okay, let's look at the next question. And then here they're asking for the KL. So I said this giving how the giving letters is important. Now look at that. If this one is K, this K, there is nothing through this way, we call it K. There is nothing here, we call it K. And then starts here L, there is nothing L, here there is nothing L, here this point is L. We can say any point is different because there is something here, let's say O. So if we draw the graph on a line, it starts K and then ends L, and then in the middle there is a O. So we have, don't forget, 1, 2, 3, 4, 5 hot capacitors. So the KO, there is one KOC here, and then KO, another one KO here. This one is C. What about OL? There is OL here, one here, and then OL, one more here. C, and then there is a between K and L. There is one more K and L. Okay. So so far I think you understand that if it's how the series combination and then parallel combination, that so this one is the it becomes C over 2, and then this one is C over 2, and then C over 2, C over 2, sorry, any more C, and C is 2C, this one is 2C, 2C, 2C becomes 1 over 2, 1 over 2, C, and then becomes like that, C and C. So C and C becomes 2C again. Okay. What about the next question? We don't have so much time. Let's do it. This one is a bit difficult. We call it K. This one is the K. This one is the L, and then L, and then L, K. Let's say M, let's say N. So let's get do it this one. Between K and L, let's say K, L, and then parallel there is M and N. K and L, as you see that, this one, C, and then MN, which one? MN, this one is C. Okay, and then the other one is KM, as you parallel here. KM. Another one is LN. Look at that. Is C, and then here C, because N. So the R, how the circuit like that. What's going to happen now? Let's take it this one. Parallel becomes 2C, and then this parallel becomes 2C. If this one is the KL, becomes C, and then here becomes 2C, and then 2C, and then there is a C here. What happens now? So this all is series and then parallel to the C. So we are sure, right? Is 1, 2, 3, 4, 5, 6, 5, 6. That's right. C becomes 2C, 2C, C. Okay. Now, when we write that between this one, 2C, C, 2C is a series combination. Becomes what? C equivalent 1 over C plus 1 over 2C plus 1 over 2C equals 2, 2, 1, 1, 4 over 2 C equivalent. So C equivalent becomes 2C over 4 or C over 2. So our new how the circuit becomes like that. This one is the C, this one is the C over 2. So what happens is C and then C over 2, C and then C over 2 becomes here CKL is equal to sum of this 3C over 2, the answer. I hope you understand. So let's see the next question. Okay, in this question asking again the equivalent resistance between K, L. So let's put the letters again, K, L, let's say different one, M, M, M. Okay, this one is important, please. So you see that this capacitance between M and M, this one is not working, means that, okay? If it's not between two different letters, if it's between the same letters, means that not working. Okay. So it's any more easy. So it starts K and then L and then M here and then ML, this one and then this one is parallel each other. You can draw like that, parallel. And then between KM also, this one is KM, this one is KM. There is one more parallel here. C. Okay, you know that anymore. This one is the 2C. This one is the 2C because of the parallel. Anymore becomes series. So 2C and then 2C is the series combination. Where is that? Series combination here. So we have to add them. CKL is equal to, 1 over CKL is equal to 1 over 2C plus 1 over 2C. So the CK is equal to 2 over 2C. So the C equivalent becomes C. Okay. So let's look at the next question again. Oh, it's a good question. And this type of question, don't forget using give letters here, L, this K, M, let's say, here M, because there's nothing here, M, here M. Okay, so this one is cancelled as you see that. So we can write the others, you know, KM, they are parallel, and then ML, they are parallel. So when you draw that ML, so between KM there are 3 capacitors connected parallel, and then between ML also 3 how the capacitor connected parallel to. So what happens if they are parallel? We are adding. So Km becomes 3C, and then another one becomes 3C. This one is the 3C. So now what happens is the series combination. Now 1 over C equivalent is equal to 1 over 3C plus 1 over 3C. So equals 2 over 3C, 1 over C equivalent. So the C equivalent is equal to 3C over 2. Okay. So what about the next question? You ask me this one. In this question, not difficult, asking for the qx and then qy. If you draw this graph is understandable, it's really easy. We can draw this graph like that. Yes, we can write like that for C. This one is the y, this one is the c, this one is the 2c, this one is the x. Can you see? And more, it's easy. What we have to know here, if it's the parallel one, is the v is the same. Can you see? That one is the v is the same. So you know, what about the q? Asking for q. So we can take it to C equivalent here. So C equivalent here for how the series combination is equal to 1 over C plus 1 over 2C. So it becomes 2C over 3 here. What about here? 4C over 1 over 4C plus 1 over 4C becomes 2 over 4C. Make it reverse, it becomes 2C. Okay. So the V is V, here the V is V, we can write Qx. Qx is equal to, you know, CV. So the Q is equal to CV, the formula, you know that. CV, what is the C for X? C times V. Sorry about that, we are going to take this how the C equivalent here. Why? Because here the Q is the same for this one and then this one, but V is not the same. So we are going to take this one. So the V times 2C over 3. What about the QY? 2C times V. 2C1. So it becomes 1 over 3. Okay. What about the next one? Total energy stored in caps, figure 1 and then figure 2. Total energy stored. Okay, we are going to find again this, if it's the parallel, if it's the series. Let's find now. It becomes any more 2C and then U. Here becomes C over 2, becomes 1 over C plus 1 over C. Okay, and then which formula is useful for us? You know the C and then U, so the energy is equal to 1 over 2 times CV squared. So let's write for E1. E1 is equal to 1 over 2. The C equivalent is the 2C and then V is U. U is squared. What about E2 is equal to 1 over 2 and then C equivalent is C over 2 times U squared. And then when you take it the ratio, what happens? This one is always gone, this one goes up, so it becomes 4. Okay, well, let's look at the next question. Okay, in this question, again the EX over EY. Please be careful in this question, not asking for the same potential or any first statement, any first condition. There is no. Just look at the graph and then take it how the terms. But firstly, you have to be sure which formula is good for you. It's how it suits for you. So look at that, U and Q, which formula we are using. So this formula is the half times Q over V. but here the for x is 2u. And then what about the y? Look at this y, 1 over 2 times 2q times u. So as you see, that is the same, and this one is the same, the ratio is 1. Okay, let's look at the next question. Okay, here also we have to draw this circuit as more understandable. So let's write here the K, because there is nothing through this way, and then there is 2C. We have to change our letter here, M, so N, so O, let's say. Okay, so we are going to this way, so I excuse this, how the circuit to this way. So I take it 2C, and then 2C is series combination. So for series combination, we said 1 over 2, it becomes 1. So it becomes 2, and then 2 becomes is the 1. So C and C becomes parallel, becomes 2C. And again, we see that 2C and then 2C series again. So, or I draw this one, 2C and then 2C again. 2C, and then C, 2C, okay, KL, and again 2C becomes C, C and C becomes 2C, and then now our new, how the one becomes like that, circuit, 2C, and then KL, so 2C and then 2C is series combination. What is the series combination? 1 over 2C plus 1 over 2C equals 2 over 2C. So the C equivalent KL is equal to C. Okay, let's look at the next question. In this question, about if you know this formula, you can solve. Let's write for Cx. Cx is equal to epsilon times A over D. What about Cy? Cy is equal to epsilon times A over 2 over 2D. What about Cz? Cz is equal to epsilon. Here the wooden. Here this one is the air. Let's say air. This one is the air. 2A over 2D. Now when you write again this, how the air